G'day and welcome to one of my videos. In this video we're going to have a look at how we can use the fundamental counting principle to determine the number of arrangements or possibilities of an event. So first of all, the fundamental counting principle states that if the first event has P outcomes and the second event has Q outcomes, and they just represent some sort of numbers, then the total number of outcomes for the two events is the product of those two. So what I mean by that is if a coin has two outcomes and another event like a die has 6 outcomes, then we can work out the total number of outcomes by multiplying those together. So let's look at a few examples, and I will do quite a few in this because there are different types that we need to consider. And if you think that you understand one, fast forward or rewind and go back and so on and pause so that you understand. So let's have a look at the number of outcomes for a pair of dice. So we know that each die has 6 possible outcomes. So the number of outcomes altogether is 6 for the first die and 6 for the second die, because we're talking about a pair of dice, and multiply those together and we get 36 possibilities. Now we would have seen this in my previous video about determining the sample space, and when we used an array or a table we came up with those 36 possibilities in the sample space. That comes up with the list of the sample space, the list of the possibilities, but our fundamental counting principle tells us how many only, not what the actual list is. So let's have a look at another example. Let's find the number of outcomes for a coin and a die. So die is singular for dice, okay, if you're not familiar with that. So a coin, it has 2 possibilities and the die has 6 possibilities. So the number of outcomes is 2 for the coin, 6 for the die. So let's multiply those together so there's 12 possible outcomes altogether. Now what I could do is a table to come up with those 12 possibilities, but remember this is only finding how many, not what the actual list of the sample space is. Alright, so let's have a look at something that might be a little bit more familiar with you. Let's find the number of outcomes for a 4-digit PIN code, so your personal identification number. So when you go to your ATM or whatever you're using on your phone to unlock your phone, we're going to have a look at how many possibilities there are if it is a 4-digit code. So each position, and I'm going to talk about positions this time, has 10 outcomes. So your first digit. So let's have a look here. I'm going to put my positions there. There are 4 positions for the 4 digits. The first position can have 10 possibilities, including 0. So 0 to 9, there are 10 possibilities. Now the second position, it can be repeated. So I can have the same digit twice in this second position. So there are also 10 possibilities. Then we can have a look at the third position. Again, digits can be repeated, so we can also have 10 possibilities there. And the final position, a further 10 possibilities. And what we need to do with those is multiply them all together, and we end up with 10,000 different possibilities for a 4-digit PIN code. Now we could actually go and write down that list, but you're going to find that you're going to have 10,000 different ones. So very time consuming, and I don't suggest that you do that. So let's have a look at another example. One a little bit more local here. In Wauchope, the Whoop Whoop Cup, which is a horse race, is held on Boxing Day each year. Now if there are 8 horses in the race, and we're going to assume that each horse has the same chance of winning, we're going to find the total number of possibilities that they can actually finish the event. We're not going to have any dead heats. We're just going to say that we have 8 different positions. So let's have a look at the number of outcomes. And what I've done here is I've got 8 horses, so I've got 8 positions that can be filled. Obviously, we want all of them the one we're looking at wants to come first, but we know that that's not always the case. So let's have a look. So there are 8 possibilities, 8 horses that could come first. Now, horses cannot finish in 2 or more positions. So once you've got one horse, one out of the 8 finishing first, that first position is filled. So now I only have 7 horses to fill second place. And then once I've got first and second place, there are 2 horses already gone or counted for. So there are 6 ready to fill third, and then 5 for fourth, and so on. So 4 for fifth, 3 for sixth, 2 left for seventh, and then 1 horse obviously has to come last out of those. So now to work out all the possible outcomes, we multiply those together, and we end up with 40,320 different combinations there. Now we can actually get that by using our factorial button on our calculator. It looks like an exclamation mark. So on our calculator, we just press 8 factorial button. We tend to use the Casio FX82 AU+2, so it's just underneath the on button. And just press 8, then that button, and equals, and we get the 40,320, so that we don't have to type all of that into our calculator. So the factorial button just goes 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So what I'm going to do now is look at a variation of that, and I'm going to stay with the Whoop Whoop Cup and have a look at the number of trifectas that are possible. So what is a trifecta? Well, it's picking the first, then second and third place in order. So let's have a look at finding the number of possible outcomes. We've got our 3 positions, first, second and third. Now we're looking at any of the 8 horses, remembering we're going to say they have an equal chance of winning. Any of the 8 horses coming in first, so I've got 8 possibilities that can go in there. And again, once I've got first filled, I've only got 7 possibilities that can come second, and third, we've got 6 possible horses left to come third. So this time we're not worried about fourth, fifth, sixth, etc. So we multiply those together and we've got 336 different possibilities there. So we've just narrowed it down into positions there and used our fundamental counting principle to work out those 330, that there are 336 possibilities. Again, we're not after the sample space and listing all 336 of them, just how many. Okay, so let's have a look at a different type of question. We're going to say that we're going to a cafe and they offer 3 different entrees, 5 different main meals and 2 different desserts on their menu. Each time we go there, we're going to have a 3-course meal. So one entree, 1 main meal, and 1 dessert. We're going to look at how many different 3-course meals we can have. So the number of meals, we've got 3-course meal here, entrees, mains, and desserts. So we can have 3 entrees, 5 main meals, 2 desserts, multiply those together, and we've got 30 different possibilities. So I could even alter the question and say, if we went back every day, how many consecutive days would I go back before I then repeat a meal? So we would then be going 30 different days. Alright, so let's be a little bit more specific again. We're going to have a look at an example of 6 people who are running for captain and vice captain. How many different ways can that captaincy and vice captaincy positions be filled? So, number of possibilities. There are 2 positions, captain, vice captain. So what we're going to do there is then have a look at that there are 6 people who can fill the captain position, and then there's 5 left for the vice captaincy. And so once they're filled, that's it. We've got 4 people who miss out, and we multiply those together, and again we get 30 different possibilities. Again, we could do a systematic list there or a table if we knew names, etc. But this is a quick way of just determining on how many. And let's do a little bit more complicated one. We're going to have a look at a registration plate or a number plate on a motor vehicle. And in this situation, our number plate that we're looking at has 2 letters, followed by 2 digits, and then followed by a further 2 letters. So how many different possibilities are there? So 2 letters, 2 digits, followed by 2 letters. So we know 26 letters in the alphabet. Once one's used, I can repeat it. Then my digits, 10 of them and 10 of them, and then back to our letters of the alphabet, 26 and 26. Multiply those together and we get 45,697,600 different possibilities there. Quite a lot. And for Australia, that's more than what our population is. For other countries, that's nowhere near enough different possibilities. So there would have to either be more letters or different ways that we can put our letters and numbers together to create more possibilities. So what you now need to do to get better at it is to practice again, and just like in sport, the more you practice, the better you become. So I hope you have found this useful and that you then get better at working out how many arrangements or possibilities there are in events, especially multi-stage events.